Linked lists. When data is stored in a computer, the processor can store it in any location provided it can get the data back. In order to get the data back, each of the locations where the data is stored is given an address so that if the computer can remember the address of where it put some information, it can easily retrieve it. If everything has to be in the index, then the index can get very large. It seems reasonable to try to cut down the size of the index by grouping things together under one index entry. One method for doing this is by using an array. The 20 people in the set could all be found by the one reference to name $, which pointed to the location of the array. There are two major problems with arrays. The first is that if the size of the set grows because a new student joined, there is no room in the array to store the information. This is because the array size has to be predetermined. The array could be made much bigger, say size 50, so that we are sure it will never be too small, but this leads to the second problem, that most of this space will never be used, consequently wasting valuable memory. These problems can be overcome by using a linked list. A linked list of data items tells the computer to store the data in any location and to link it to the previous data item by giving the previous data item the address of the new one. That sounds very complex. The idea is simple if we look at it in diagram form. Each of the locations that can hold data are given an address, and the address of the first data in the list is stored separately. This tells the computer where the first piece of data is. If the first data item is not the one that is wanted, the computer goes to the next piece of data by using the address that is stored with the data. These addresses are called pointers, the last one of which has to be one that cannot possibly exist so that the computer knows it has reached the end of the list. Notice that the two problems associated with arrays no longer exist. Also, notice that a whole area does not have to be reserved anymore. Here we have two items of data mixed up with the names in the list. It doesn't matter. In reality, the values in the list will be scattered all over memory anyway, not close to each other like in the diagram. Linked lists are often drawn showing the data in boxes and the linking addresses as pointers. This is the better method for describing a list. Don't lose sight of the fact that the arrows are really address references. Note, the jagged line signifies that there are a number of others which would fit in there, but they are not shown. To initialize a list, all that needs to be done is to create a new start pointer for this list and add it to the index of start pointers for all the other lists. To search through the list for a particular piece of data, follow these rules. 1. Find the correct list in the index of lists. 2. Follow the pointer to the next item. 3. If the item is the one being searched for, report that it is found and end. 4. If the pointer shows that the end of the list has been reached, report that the item is not there and end. 5. Go to step 2. Try to write this algorithm in pseudocode using a while, end while loop. To remove a value from a list, simply change the pointer that points to it into one that points to the next value after it. Note that Sahin's data is still there, it is just that there is no way of getting to it, so it might just as well not be.